Quantum on the Treadmill, Episode 13. Wolfgang Pauli, Unlucky Numbers, and the Problem of Chance. Welcome to Episode 13 of Quantum on the Treadmill, and because this is Episode 13, I thought we should probably talk about bad luck. 13 has had a strange hold on human imagination for centuries. Buildings skip the 13th floor. Hotels avoid room 13. Friday the 13th has become shorthand for a day when things are somehow more likely to go wrong. And of course, rationally, we know that makes no sense. There is nothing physically different about the number 13. It cannot make an elevator malfunction. It cannot cause your flight to be delayed. It cannot make you lose your keys. But if something bad does happen on the 13th, we notice it and we remember it. That is what makes superstition interesting. It may tell us less about the universe than it tells us about how human beings deal with uncertainty, which brings us back to an old friend in this series, Wolfgang Pauli. We have already talked about Pauli and his enormous contribution to quantum mechanics, particularly the exclusion principle, so I'm not going to retell that story here. Instead, I want to talk about another principle associated with his name, one that definitely did not win him a Nobel Prize. His colleagues called it the Pauli Effect. The joke among physicists was that whenever Wolfgang Pauli entered a laboratory, something broke. An instrument would stop working, an experiment would fail, some elaborate piece of equipment would mysteriously malfunction. Pauli was a theoretician, and there has always been a friendly rivalry between theoretical and experimental physicists. But Pauli's reputation apparently became something more than the usual joke. People genuinely began telling stories about equipment failing whenever he appeared. The great experimental physicist Otto Stern was supposedly reluctant to let Pauli enter his laboratory during important experiments. The joke was that Pauli did not even have to touch anything, he only had to walk into the room. And then there is my favorite version of the Pauli Effect story. At a physics laboratory in Göttingen, an expensive piece of equipment suddenly failed. Pauli was nowhere around. Someone apparently joked that for once they could not blame Pauli, except there was a problem. When Pauli heard about the incident, he pointed out that at almost exactly the time the equipment failed, he had been traveling by train. And his train had stopped at the Göttingen railway station. So Pauli wasn't in the laboratory. He was merely nearby. The Pauli effect had apparently become powerful enough to work at a distance. Now, obviously, this was not physics. Nobody discovered a mysterious Pauli field that destroyed laboratory equipment whenever Wolfgang entered town. It was a joke, but it is a wonderful joke because it was being told by the people helping create one of the most mathematically sophisticated theories in human history. Even physicists were not immune to superstition. And think about how the Pauli effect would have grown. First, Pauli develops a reputation for equipment breaking around him. Then something breaks while Pauli is present. Everyone remembers it. Another experiment fails. Another story gets added. But what about the 100 times Pauli walked into a laboratory and absolutely nothing happened? Nobody tells those stories. Eventually, the coincidences become a pattern, and the pattern becomes a legend, which is not very different from Unlucky 13. Something bad happens on the 12th, and we forget it. Something bad happens on the 13th, and we say, there it is again. But this is where the story becomes much more interesting because Pauli and the other founders of quantum mechanics were wrestling with a far more serious question about chance. For centuries, physics had encouraged a powerful idea. If we knew enough about a physical system and we knew the laws governing it, then in principle we ought to be able to, predict what happens next. Maybe the calculation would be incredibly difficult. Maybe we would lack enough information, but underneath everything was assumed to be a chain of cause and effect. Quantum mechanics began to challenge that idea. Consider radioactive decay. Take a radioactive atom. Quantum mechanics can tell us the probability that it will decay during a particular period of time. Take a huge collection of radioactive atoms, and those predictions become extraordinarily reliable. But ask a different question. Exactly when will this particular atom decay? Quantum mechanics does not give us a precise answer. And that is very different from simply saying that our instruments are not good enough. The standard interpretation says there may not be a hidden clock inside the atom waiting for us to discover it. We get a probability. That idea deeply bothered Einstein. His objection is usually summarized by the famous line, God does not play dice. Einstein suspected that quantum mechanics was incomplete. Perhaps there was some deeper description underneath it all, some hidden layer that would eventually restore the deterministic universe he expected. Bohr and others were much more willing to accept something radical. Maybe probability was not simply describing what we did not know. Maybe probability belonged to nature itself, and suddenly our silly story about the number 13 becomes surprisingly relevant. because human beings really do not like unexplained events. If something happens and we immediately ask, why? What caused that? What did I miss? Was it because today was the 13th? Was it because Polly walked into the room? There must be something. And most of the time, that instinct is extraordinarily useful. Science itself depends on it. People once explained disease with curses until we discovered germs, and people explained lightning through mythology until we understood electricity. We see an unexplained event and search for a mechanism. That instinct has produced some of humanity's greatest discoveries. Then quantum mechanics arrives and says something deeply uncomfortable. Sometimes the best answer nature gives us may simply be there is a probability that this will happen. And Pauli's story gets stranger still. Later in his life, Pauli developed a remarkable intellectual relationship with Carl Jung. Jung was interested in what he called synchronicity, meaningful coincidences that appear connected even though there is no obvious causal mechanism between them. And Pauli, the physicist, who had somehow become surrounded by stories of impossible coincidences, became deeply interested in those questions. The two discussed physics, psychology, dreams, symbolism, causality, and coincidence. This is where we need to be careful. Quantum mechanics does not prove synchronicity. It does not prove supernatural causation. And the Pauli effect was not evidence of some unexplained quantum force. Pauli remained a rigorous physicist. But what fascinates me is that one of the people helping dismantle the classical idea of certainty, also became interested in the boundaries of causality and coincidence. In other words, Pauli kept finding himself near the same question. When two things happen together, what exactly are we justified in saying about the connection between them? That may be the real story of episode 13. 13 is not interesting because it is unlucky. It is interesting because we think it might be. The Pauli effect is not interesting because Pauli somehow broke laboratory equipment with his presence. It is interesting because some of the smartest scientists in the world could watch a handful of coincidences accumulate and turn them into a story. Human beings are pattern making machines. We observe events, we connect them, we create explanations. Sometimes those explanations reveal genuine causality, sometimes they lead to scientific breakthroughs, sometimes they create superstitions, and quantum mechanics introduced an even stranger possibility. Sometimes there may be no deterministic story underneath the individual event at all. That does not mean quantum mechanics says anything can happen. Quite the opposite. Its probabilities follow extraordinarily precise mathematical rules. But the individual outcome can remain unpredictable. And perhaps that is one of the deepest intellectual shocks of quantum mechanics. It did not merely tell us that atoms were strange, it forced physicists to confront the possibility that uncertainty itself might be part of nature. Which makes episode 13 feel like exactly the right place for this story. For thousands of years, humans have looked at uncertainty and constructed explanations. A bad harvest meant angry gods, a comet meant disaster, 13 meant bad luck. A broken experiment meant Wolfgang Pauli must be nearby. Then quantum mechanics came along and gave us a very different language. Not superstition, not magic, probability. Maybe that is the lesson of the Pauli effect. When something unexpected happens, our brains desperately want to create a story. Sometimes the story is correct, and sometimes the story changes science, and sometimes the story is simply that it happened on the 13th. The hard part is knowing which one you are looking at. And if my treadmill suddenly stops before the end of episode 13, I'm still blaming Pauli.